Hi friends, today I will be explaining Physics Paper 11 May-June 2016. Question 1 states, the diagram shows an enlarged drawing of the end of a meter roll. It is being used to measure the length of a small feather. What is the length of the feather? So we will start measuring the length of the feather from the stem, which is 10 millimeter, and then at the end of the leaf it is 29 millimeter, because here it is divided into two halves between 20 millimeter and 30 millimeter, so this will be 25, then 21, 22, 23, 24, then 25, then 26, 27, 28, 29 and 30. So over here it will be 29 millimeter, and over here we have 19 millimeter, 29 millimeter, 19 centimeter and 29 centimeter. Then over here we have starting length is 10 millimeter and ending length is 29 millimeter. So we will write here 29 minus 10, which will be 19 millimeter. So A will be the correct answer. Question 2 states, a train begins a journey from a station and travels 60 km in a time of 20 minutes. What is the average speed of the train? So first we will convert 20 minutes into seconds, because over here we have all the values in meters per second. So we will do 20 multiplied by 60, which will be 6 2s are 12 and 1200 seconds. Then we have the speed, which is 20 kilometers in a time of 20 minutes. So we will convert 60 kilometer into meters, which is 60 multiplied by 1000, because 1 kilometer is equal to 1 kilometer is equal to 1000 meters, so which will be 60,000 meters. Then we will calculate the average speed of the train, which is average speed is equal to distance divided by time. So the value of distance is 60,000, so 60,000 divided by 1200 seconds. So we will write 1200. This will be 0 0 and 0 0, which will be 600 divided by 12, which will be 50 meters per second. So over here C will be the correct answer. So question 3 states, two runners take part in a race. The graph shows how the speed of each runner changes with time. So in the speed time graph, runner 1 speed increases constantly throughout the graph, whereas the speed for runner 2 increases rapidly at the starting and then it keeps decreasing at the end. So the question states, what does the graph show about the runners at time t? Both runners are moving at the same speed. Runner 1 has zero acceleration, and C states runner 1 is overtaking runner 2. D states runner 2 is slowing down. So A will be the correct answer, because at T over here the graph shows that the speed for runner 1 and runner 2 are both equal, so both runners are moving at the same speed. So A will be the correct answer. Then for B, runner 1 has zero acceleration, which is wrong, because runner 1 is constantly accelerating. So it does not have zero acceleration, it has constant acceleration. C states runner 1 is overtaking runner 2. This is also wrong, because at first runner 2 overtakes runner 1, but At time t, runner 1 and runner 2 are at equal speed. Then at d, runner 2 is slowing down. Wrong. They both are at constant speed. So A will be the correct answer. Question 4 states a cup contains hot liquid. Some of the liquid evaporates. What happens to the mass and what happens to the weight of the liquid in the cup? So, what is mass? Mass is the amount of matter in an object, whereas the weight is the force exerted on the object by the gravity. So, over here, as the liquid evaporates, so mass of the liquid will decrease. Over here it will decrease, and the weight of the liquid exerting weight that is exerting on the liquid will also decrease. So A will be the correct answer, whereas in B it says it decreases, mass decreases but weight stays the same. This is wrong because the exerting force will also decrease as the liquid evaporates. Then in C, mass stays the same. This is wrong because over here liquid evaporates, so there will be less weight of the liquid remaining in the cup. And then in D, both stays the same, which is also wrong. So A will be the correct answer. Question 5 states an object has a mass of 50 kg. The gravitational field strength on Earth is 10 newtons per kg. The gravitational field strength on a distant planet is 9 newtons per kg. What is the weight of the object on Earth and what is the weight on the distant planet? So the formula to calculate the weight is W is equal to mass times gravitational field strength. So for Earth it will be 50 multiplied by the gravitational field strength, which is 10. So this will be 500 newtons. And then for distant planet it will be 50 multiplied by 4, which will be 200 newtons. So D will be the correct answer. Question 6 states a student wishes to determine the density of an irregularly shaped stone. First he finds the mass of the stone, next he lowers the stone into a measuring cylinder containing water. The diagram shows the measuring cylinder before and after the stone is lowered into it. What should the student calculate? What should the student calculate to the density? How should the student calculate the density of the stone? So the formula for density is D is equal to mass divided by volume. So the mass will be over here mass of the stone divided by the volume. So in first reading we have only the water level, and then in second reading we have the level of water plus the stone inserted into the measuring cylinder. So we will take the reading for the second measuring, reading 2 minus reading 1. So reading 1 minus reading 2. So over here in A it's mass of stone multiplied by reading 2. This is wrong. Then mass of stone multiplied by reading 2 minus reading 1, which is wrong because it should be mass of stone divided by reading 2 minus reading 1. So D will be the correct answer. Question 7 states which is an example of a force. So energy is a force. This is wrong. Then B is the power, which is not an example of a force. Then pressure is also not an example of the force. Weight is an example of a force because the amount of force that is exerted on the object is known as weight. So D will be the correct answer. Question 8 states the diagram shows an object of weight W and an object of weight Z balanced on a uniform meter rule. Which equation relating to W, Z, A and B is correct? So the formula to calculate the equilibrium balance value is weight of A multiplied by distance of weight from A from pivot is equal to weight of B multiplied by distance of weight B from pivot. So over here we will do weight W multiplied by A is equal to Z multiplied by B. So C will be the correct answer. Question 9 states a skier walks from the bottom of the ski slope to the top and gains 10,000 joules of gravitational potential energy. She skis down the slope. At the bottom of the slope, her kinetic energy is 2000 joules. How much energy is dissipated in overcoming friction and air resistance as the skier moves down the slope? So we will do 10,000 minus 2000, which will be 8000 joules, that is dissipated in overcoming friction and air resistance. So B will be the correct answer. So question 10 states a coal-fired power station generates electricity. Coal is burned and the energy released is used to boil water. The steam from the water makes the generator move and this produces electricity. Which words are used to describe the energy stored in the coal and the energy of the moving generator? So the energy that is stored in the coal is chemical energy, and then in generator when the steam from the water moves the generator, the output of the energy that is created from the generator is kinetic energy. So B will be the correct answer. Question 11 states 4 different children run up the same set of stairs. For which child is the usual power to climb the stairs the greatest? Mass of the child per kg. At 40 kg, the child takes 15 seconds. When a child of 50 kg climbs the stair, it takes him 25 seconds. Then for 60 kg, it takes 25 seconds, and for 70 kg, it takes 15 seconds. So the question states which child is the usual power to climb the stairs the greatest? It's the 70 kg because it climbed the stairs in less time as compared to 60 kg child and 50 kg child. So D will be the correct answer, and we will mark D as our final answer. So question 12 states the diagram shows three vases each with the same base area. Each vase contains water of the same depth. Which statement about the water pressure at points P, Q and R is correct? So A states the pressure at point P is the greatest. Wrong, because in all three vases we have equal height of water, so the amount of pressure exerting on each of these vases will be equal. Then the pressure at point Q is the least. This is wrong because it does not depend on the how vase is made or the distance circumference of the vase is less. So B will be also incorrect. Then C, the pressure at point R is the greatest. Over here it is opposite to was Q because over here there is a greater circumference. So this is wrong because it depends on the height of the water and amount of pressure exerted. So in three vases there will be equal pressure exerted. So C will be incorrect and D will be correct because the pressures at point P, Q and R are the same. So the final answer will be answer D. Question 13 states the diagram shows a simple mercury barometer. The atmospheric pressure increases. Which distance increases? So when the force exerted on this level increases, so the distance between X and Y will decrease, as the mercury will move upwards in the barometer ups over here, so the distance between V and W will decrease, but the distance between W and Y will increase, because if the level W rises up till this point and level Y stays constant, so the distance between W and Y will increase, so B will be the correct answer. Question 14 states which statement about evaporation is correct. So A states evaporation causes the temperature of the remaining liquid to decrease. This is true because here example, if we take a pot and we have water molecules in the pot, so when the heat is applied at the base of the pot, the base molecules over here be be at higher temperatures, and they will move upwards to the top of the surface of the pot or pan, and then from the surface they will escape into the air or evaporate. So the remaining molecules in the pot will and the temperature in the remaining molecules in the pot will decrease. So A will be the correct answer, but in B, evaporation does not occur from a cold liquid near its freezing point. So B is not correct. C states evaporation does not occur from a dense liquid such as mercury. This is wrong. And then in D, evaporation occurs from all parts of the liquid. Wrong. So A will be the only answer in question 14. Question 15 states a gas is stored in a sealed container of constant volume. The temperature of the gas increases. This causes the temperature of the gas to increase. This causes the pressure of the gas to increase. What happens to the gas molecules during this pressure increase? So when the temperature increases, the movement of the gas particles in the container increases, and they are moving at a higher speeds as compared to when it was at a cold temperature. So they will exert greater pressure on the internal surface of the cylinder or the gas container. So the average kinetic energy of the molecule increases. This is correct. A will be the correct answer. Whereas in B, the average separation of the molecule decreases. This is wrong, because when the temperature decreases, the distance between the molecules will decrease, and in had or whereas at high temperature, the separation of the molecule increases. So B will be the wrong answer. Whereas in C, the average separation of the molecule increases. This is wrong. And then D, the volume of each molecule increases. This is also wrong, because it's a gas molecule, gas particles, so they will move at a higher speed but they cannot expand. So A will be the correct answer. Question 16 states a substance loses thermal energy or heat to its surroundings at a steady rate. The graph shows how the temperature of the substance changes with time. So first, the temperature of the substance is at high temperature, and first it decreases and reaches to its boiling point, because over here when it decreases from point P to Q, then it's at normal temperature, because it is not at 0 degrees, but it is above 0 degrees, so it means it is at its normal temperature. So the question states, what could the portion PQ of the graph represents? So over here I stated that the temperature decreases from extreme high temperature to its boiling point at high temperature. Then from P to Q it reaches, after Q it reaches to its normal temperature. So from P to Q the liquid is cooling. In A, it states gas is condensing, which is wrong, because if it was inverse over here, if I show of P to Q, if it was moving from P to Q, then it can be gas condensing, but it's wrong. Then in B, it's gas cooling. So if the temperature is, if they stated P over here and Q over here, then we can say that it's the gas is cooling down. But in C, it's liquid cooling. So P, from P to Q, uh, it's cooling because after Q it reaches its normal temperature, which is above zero but not extreme high temperatures. So C, and then it's in D, it's liquid solidifying, which means it's turning into ice or reaching 0 degrees. So D is also incorrect. So C will be the correct answer. Question 17 states a student wishes to check the upper and the lower fixed points on a Celsius scale thermometer. She has four beakers P, Q, R, and S. Beaker P contains a mixture of ice and salt. Beaker Q contains a mixture of ice and water. And beaker R contains boiling salt solution. Beaker S contains boiling water. So, which two beakers should she use to check the fixed points? So, she has first check the the lower fixed point on a Celsius scale. Then she should use the mixture of ice and water, because in ice and water the temperature of water will be at 0 degrees, and so beaker Q will be first used to check the lower fixed points. Then she will use beaker S, which contains boiling water, to check the upper fixed point, which is 100 degrees. So which two beakers should she use to check the fixed point? So D will be the correct answer, because over here in Q she would first put the thermometer in ice and water, then in boiling water. So D will be the correct answer. Question 18 states the same quantity of thermal energy is supplied to two solid objects X and Y. The temperature of object X is greater than the temperature increase of object Y. So which statement explains this? X has a lower melting point than Y, which is wrong, because over here X has a higher melting point than Y. Then in X has a lower density than Y, which is also wrong. Then C, X has a lower thermal capacity than Y, which is correct, because X absorbs heat energy or thermal energy greater as compared to object Y, so it has a lower thermal capacity. So C will be the correct answer. And in D it states X is a better thermal conductor than Y, which is also wrong, because over here it's not measuring temperature at one side of object X and on the other side of object X. So D will also be wrong. So C will be the correct answer. So question 19 states a liquid is heated in a beaker. The density of the liquid changes as temperature increases. This causes energy to be transferred throughout the liquid. How does the density change, and what is this energy transfer process? So the density, what happens to the density? As the liquid is heated, the hot molecules of the liquid are evaporated, so the density will decrease. Whereas in energy transfer process, it is either conduction or convection. It's not conduction, because conduction happens through solid, so conduction will be wrong. And then for convection, convection will be correct, because convection means that the process of transferring heat throughout the liquid. So B will be the correct answer. And in A, density decreases, but energy transfer is conduction, so this is wrong. Then in C, density increases, but the process of energy transfer is conduction, which is also wrong. And D, which is density increases, no, this is wrong, because it decreases. And then the energy transfer process is convection, which is correct. So B will be the final answer. Question 20 states a rod is made half of glass and half of copper. Four pins A, B, C, and D are attached to the rod by wax. The rod is heated in the center as shown. The pin falls off when the wax melts. Which pin falls off first? So, as we know that copper is a better conductor of heat as compared to glass, so pins C and D will fall off first before pin A and B. But over here, as pin C is closer to the heat, so as heat is being transferred throughout the copper rod, so first pin C will fall before, and it will fall before pin D. So pin C will fall first before A, B, and D. So C will be the correct answer.